Hello everyone, my name is Yuvan Sukla. I welcome you all in my YouTube channel Let's Talk. Here I am with the 14th part of the running video series. This video series is very helpful for every geology student. So if you have not subscribed my channel yet, please do subscribe so that you never miss an update. In this part, I will solve next 25 questions of Sagar University 2020 question paper. So let's start from the first question, which says, a neutral refractory is prepared from one of the following. So first of all, what are refractory minerals? Refractory materials are those that can resist even high temperature without changing its composition. So like and these are of acidic refractory, neutral refractory and basic refractory. Example of acidic refractory minerals are kyanite, andalusite and sillimanite and even quartz. So first option is of acidic refractory. Second is neutral refractory, and example of neutral refractory minerals are like graphite, asbestos, chromite and zircon. Next one is basic refractory, and example of basic refractory materials are magnesite, dolomite, olivine and corundum. Next one is silica. Silica is also example of acidic refractory. As I told you that quartz is acidic refractory mineral. So this question is asking about neutral refractory, so the correct answer of this question will be graphite. Other than graphite, other neutral refractory mineral, as I told you, are asbestos, chromite and zircon. So if these were also present, then the correct answer will be these. If the question were asking about basic refractory mineral, then the correct answer would be magnesite. But if the question were asking about acidic refractory mineral, then it will become MSQ, and the correct answer will be kyanite and silica. Other than kyanite and silica, andalusite, sillimanite are also acidic refractory minerals. Next question is, a fine grained, compact, snow white, massive variety of gypsum. So first of all, one thing you should notice that the question is asking about massive variety of gypsum. So you know that there are three varieties of gypsum: alabaster, selenite and satin spar. Out of which satin spar is fibrous variety, selenite is clear needle like variety, while asbestos is a fine grained, compact, snow white, massive variety of gypsum. So the correct answer of this question will be alabaster. But most of you can confused between plaster of Paris, that you have seen this plaster of Paris and you can say that this is also fine grained, compact, snow white. But yes, this is fine grained, though this is snow white, but this is not the variety of gypsum, as gypsum composition of gypsum contains CaSO4 dot 2s2o, but composition of, if you see the composition of plaster of Paris, you will see that this is CaSO4 dot half s2o. So there is a difference in chemical composition of plaster of Paris and gypsum. So this is not the variety of gypsum. Okay, and question is asking about variety of gypsum, so the correct answer will be your alabaster. But if you consider gypsite and gypsum anhydrate, so gypsum anhydrate is simply CaSO4. This is also not the variety of gypsum, and gypsite is a aluminum ore. So the correct answer of this question will be alabaster. If this question were asking about clear needle-like variety of gypsum, then the correct answer will be selenite. And if this question were asking about fibrous variety of gypsum, then the correct answer will be satin spar. Coming to next question. Next question says, on the basis of genesis, which of the following is an odd member? Okay, so these are the options. If you say that ilmenite, magnetite, chromite and sphalerite. So if you remember the composition of these elements or these ores, these minerals, then you can easily differentiate between among them. So first one is ilmenite, and the composition of ilmenite is FeTiO3. Then is magnetite, and composition of magnetite is Fe3O4. Chromite is FeCr2O4 and sphalerite is ZnS. So first of all, one thing to be noticed, that these ilmenite, magnetite and chromite, all these have Fe in itself. And second thing that you can witness or you can observe, that these all three are oxides. Ilmenite is FeTiO3, magnetite is iron oxide and chromite is Fe chromium oxide. While is considering the sphalerite is a sulfide. So clearly you can distinguish among these with the help of its composition, or you can say its genesis. So the correct answer of this question, which is odd member, so the correct answer will be sphalerite. Next question is, tin, tungsten and molybdenum are invariably associated with. So tin, tungsten and molybdenum ore are, and mostly these are associated with pegmatites and granitic rocks, but these are also lithophile elements and are occurred in pegmatite. And you know, pegmatite and granite, these are acidic intrusive. So the correct answer of this question will be acidic intrusive. While these are considering acidic and acidic intrusive because these have high silica content, and if any rock have high silica content, then it will considered as acidic intrusive. Next question says, tertiary marine fossiliferous sedimentary basins are the suitable sites for which deposit? So, first of all, two things you should notice in this question. First of all, the question is asking about tertiary sedimentary basin, and second one is marine fossiliferous sedimentary basin. So first one is of course tertiary, and second one is of marine fossiliferous sedimentary basin. So you will all know that tertiary sedimentary basins are suitable sites for deposits of lignite deposit, okay, and also for petroleum deposit. And the first condition says that these are especially for coal deposit and petroleum deposit. Now the second condition that these are marine fossiliferous sedimentary basin. So this clearly indicate that these are suitable for petroleum. Why? Because coal is found where there is presence of terrestrial plant matter, not marine fossiliferous. Okay, so marine fossiliferous is clearly indicating that the sedimentary basins are suitable sites for petroleum deposit. These are out of the box. So the correct answer of this question will be petroleum. And also tertiary basins are suitable for lignite deposit, while higher rank coal bituminous coal, these are found in carboniferous era. Okay, now sorry, period. Now next question is tolerance limits of all constituents in an ore minerals is termed as. So basically this is asking about the definition of a term. So first one is tenor. So you should know the definition of tenor. What is tenor? Tenor is, this is also known as grade or assay value. Okay, and it is represented in percentage, and it is what it is. It is metal content of an ore. Now it is average concentration of valuable mineral or element in an ore deposit. So this is clearly not the tolerance limit. Okay, and I told you tenor is also known as grade. So this is also the same as tenor. This is also metal content of an ore, and these are expressed in percentage. Now coming to ad valorem, this is a word, a Latin word, and in which ad means according and valorem means value. So this means according to value, and this word ad valorem, it is a commercial or sale term, you can say taxation term. So this is also not clearly the tolerance limit of all constituent in ore mineral. Now the only one option remains, that is specification, and it is clearly the definition of specification that this is the tolerance limits of all constituents in an ore minerals. Okay, so the correct answer will be specification. Next question is bacterial leaching in hydrometallurgy is applied for leaching. So bacterial leaching in hydrometallurgy is used to leach those ore deposits that are bacteriogenic in nature and are concentrated in reducing environment by sulfate reducing anaerobes, and this process is applicable mostly in sandstone type copper deposit, which include chalcocite, bornite, cobellite. And along with these, along with copper deposit, other commonly associated elements that are formed by bacterial leaching or bacteriogenic processes are uranium, vanadium, and even silver. Here you see copper and uranium both are present, but most appropriate answer, if you consider the most appropriate answer, then the correct answer will be your copper. Why? Because bacterial role via production of H2S and sulfuric acid has been instrumental in developing oxidation and supergene sulfide deposit. And you know that supergene sulfide enrichment deposit is clearly, you can say, these are copper sulfide deposit, and the ore minerals that formed in supergene sulfide enrichment deposit, you can see these are chalcocite and cobellite, these are present. And also without the precipitation of bacterial role, or without the role of bacteria, most of the porphyry copper deposit of the world would not have reached the needed enrichment. So the correct answer will be copper. Though uranium and vanadium and also silver, or these are associated with copper, red bed copper deposit or sandstone type copper deposit. So the correct answer of this question will be copper. Next question is Climax mine in Colorado, USA is famous for. So now you will see in any economic book that Climax mine is famous, world famous mine, and which is famous for molybdenum deposit. Now coming to next question. Next question says India's one of the largest SMS grade limestone captive mines of Bokaro steel plant is situated at. So first of all, there are 2-3 terms included in this question. First one is SMS grade limestone, and second one is captive mines. Okay, Now, what is captive mines? So captive mines are those that produce ore for exclusively use by the company that owns the mine. That is, these mines, one of these mines is owned by Bokaro Steel Plant, and that produce ore only for the, or you can say exclusively for the use of Bokaro Steel Plant. Okay, now next one is SMS grade limestone. So there are different grades of limestone: SMS grade limestone, cement grade limestone, SP grade limestone, that is splinter grade limestone. Okay, so among them there is SMS grade limestone. That means the limestone that is of high purity, containing very low amount of silica, now which is calcined to make lime for use in steel melting shops. Now the limestone which is used in steel melting shop. So clearly, if you see that steel melting shop, this is SMS. The limestone that is used in steel melting shops are known as SMS grade limestone. Okay, so now two things are clear: what is SMS grade limestone, and second one is what are captive mines. Now let's check the options. First one is Nagod. So Nagod in Nobasta Kolar limestone block, it is located in Nagod Tehsil, and the proposal of mining limestone was discussed on 2016 at GSI Central Region Nagpur. So clearly it is not the largest SMS grade limestone yet, because mining is still on the paper. Next one is Nandani limestone mines. It is the only one captive source of SP grade limestone. SP means sintering plant grade limestone. Now, this is one of the largest SP grade limestone, and this is the only one captive source of SP grade limestone for Bhilai steel plant. So this is the captive mine for Bhilai steel plant, and according to article, it is also one of the largest limestone mine of the Asia, and it is located in Durg, Chhattisgarh. Next one is Chittorgarh mines. Chittorgarh limestone mines produces cement grade limestone. So, and the question is asking about SMS grade limestone. Now, next one is Kuteswar. Kuteswar limestone mines are situated in Katni district of MP, and it is established in 1973 by SAIL, and this is one of the captive mine for SMS grade limestone that produces limestone for Bokaro steel plant. This question is important. Why? Because SMS grade limestone are found in very selective places. One of them are, I told you, that Kuteswar limestone unit, which is located in Katni district of MP, and the second one is Jaisalmer. In Jaisalmer, Sanu and Gotan limestone unit are present, which are SPS grade limestone unit, and these are one of the largest SPS grade limestone mines of the world. Next question is, a placer deposit formed at the site of destruction of primary source rock is called. So what are placer deposit? Placer deposit are those that are placed by some agents, like first of all is alluvial placer. Alluvial placer, these deposits are formed at or near the source rock, basically on the hill slope. Okay, and but these are found near the source rock in hill slope also, or you can say these are the deposit that formed at the site of destruction of primary source rock. So the correct answer this question will be alluvial placer. Next one is aeolian placer. Aeolian placer are those placer deposits that formed by wind action. Colluvial placer, these deposits are somewhat similar to alluvial placer, but the difference is that these deposits found at the base of the hill, but these alluvial placer, these deposits formed at the top of the hill. Next question is alluvial placer. Alluvial placer, these deposits are formed by stream action. So as far as the question is concerned, the placer deposit that formed at the site of destruction of primary source rock, the correct answer will be alluvial placer. Now next question is, hydronetic texture is typically associated with. So first of all, hydronetic texture, this is commonly associated with nickel sulfide deposits, and nickel sulfide deposits, as you all know, are formed by immiscible liquid injection process, and this is again a process of late magmatic deposit, formation of late magmatic deposit. So the correct answer of hydronetic texture will be late magmatic deposit. Next question. When a metamorphic rock undergoes significant changes in the chemical composition during recrystallization, the process of change is referred to as. So let's check the options. Now, two things you should notice in this question, that there is change in the chemical composition. Change in the chemical composition. Now, first option says metasomatism. Metasomatism, what does metasomatism means? Meta means change and somatism means body. So basically metasomatism is change in composition of rock. Okay, now second one is metamorphic differentiation. Metamorphic differentiation is clearly segregation of minerals into compositional bands. So this is clearly not question, not the definition as per asking the question. Next one is leucosome. Leucosome is nothing, it's a light colored granty component of pegmatite. Other than leucosome, there are a paleosome and melanosome also. Leucosome is light colored granty component, while melanosome is dark colored granty component, and paleosome is parent rock. Okay, so clearly this belongs to pegmatite, so this is not the one that question is asking. And this is clearly not, because B and C both are not the correct answer. So the correct answer of this question will be metasomatium, which clearly means change in composition of rock, and question is asking about this, so the correct answer will be metasomatism. Next question is, in metasomatic process, the principal chemically active fluids or volatile constituents are. So clearly we all know that in metasomatic process, the principal chemically active fluids or volatile constituent are H2O and CO2 both. Now, if the question were asking only about hydrothermal deposits, then the correct answer will be H2O only, because in hydrothermal deposit, the fluid that is mainly active is H2O, or you can say warm water. But this question is asking about metasomatic process, so correct answer will be H2O and CO2 both. Next question says, during concretion principle, the growth of okay, during concretion principle, what happened during concretion principle? So from the word itself, it is clear that this concretion means something that is constructed, okay, something that is growing. So clearly from the word itself, it is clear that during concretion principle, there is the growth of large porphyroblast or crystalline aggregates occur. For example, manganese nodules in the deep sea floor. It is grown by concretion principle. So the correct answer of this will be A. Now you can eliminate, or you can say you can answer this question by elimination method also. Like I told you that paleosome, neosome, leucosome, melanosome, these are all associated with pegmatites. So these are not associated term with concretion principle. Now next question says, the parent rock, whether metaphyletic cyst or gneiss or metagravic, designated as. So this is the definition, clear definition of paleosome, that paleosome are parent. Paleo means ancient, or you can say that are coming from earlier, and so means body. So these are the body that are, you can say these are parent rock body. Okay, so paleosome clearly indicate parent rock, whether metaphyletic cyst or gneiss. Now, what is neosome? Neosome is new body, not parent rock. Or you, okay. Now, next one is leucosome, and this neosome consists of restite and leucosome also. Leucosome is what? Leucosome is light colored granty components present in pegmatite, that is known as leucosome. So the correct answer of this question will be paleosome. Now, next question is, on melting the paleosome, on melting, the paleosome changes its composition, which is now observed as restite. So now paleosome changes its composition on melting. That is now the body that formed is new body. Okay, because paleosome changes its composition on melting. So paleosome will not be correct answer, because melting of paleosome will not produce paleosome itself. Melanosome, if the question were asking about dark colored component, then the correct answer will be melanosome, but the question is not asking about dark colored component, so this is also not the correct. Leucosome, if the question were asking about light colored component, then this will be correct answer, but this is also not asking in the question, so leucosome is also not the correct. Now only one neosome. Neosome is new means new, and some means body, I told you. So this is clearly the new body that is formed by the melting of paleosome when it changes composition, and it is now observed as restite. So clearly these are components that dissolve by partial melting, and these are also new body and also can be recognized as observed as restite. So the correct answer of this question will be neosome. Now next question is, geologists are responsible for. So if you are studying geology, if you are willing to become geologist, then you should know that what are your responsibilities, what work you have to done. So first thing that you have to explore minerals. You will have to explore minerals. You will be mineralogist. Finding groundwater supplies, you will be hydrogeologist. And building foundations for engineering projects, you will be engineering geologist. So these all are the work of geologist that you have to do if you want to become geologist. So the correct answer of this will be all of the above. Next question is, metamorphism is mainly due to the operation of. So now if there is only pressure is operating, then the metamorphism that will result is dynamic metamorphism. If only temperature is acting, then the metamorphism will be contact metamorphism or pyrometamorphism. You can say thermal metamorphism. If fluids only is acting, then the metamorphism that will produce is metasomatism. You can clearly see that we have already discussed in previous questions that metasomatism is mainly active fluids or S2 and CO2. So basically metamorphism is the operation of since all these three are types of metamorphism. So it is clear that metamorphism is mainly due to the operation of pressure, temperature and fluids. So the correct answer of this will be pressure, temperature and fluids. Next question is, which of the following has the highest compressive strength? Now why it is necessary to measure compressive strength? No, this is for engineering purposes. As I told you that geologists are responsible for building foundations for engineering projects, and for that you need rock, you need foundation, and for that you will have to check its compressive strength, that how much it is compressive. So those practical those experiments shows that quartzite is the strongest among all. Next, followed by granite, then silica cemented sandstone, then basalt, then calcite cemented sandstone, then schist, then marble, and finally shale salt and anhydrite. Anhydrite is the least, or can say weakest rock. It had the least compressive strength. Now coming back to options, granite. Now the average compressive strength of granite is approximately 1400 sorry 1500, and the average compressive strength of marble is 1000. Rhyolite, it is not considered in a text, that is you can check it in KSW, Engineering Geology by KSW. Okay, and quartzite, though it is also low, will be low than granite because it is volcanic rock, and it also don't have crystals, so it will be, I think, less than granite. Next one is quartzite. Quartzite is metamorphic rock and it is a compact rock, and the composition of this is silica, okay, which have the hardness of 7 itself and have metamorphosed. So the quartzite have the highest compressive strength and it is the strongest rock, as this is mentioned in the table. This you can check in MP Billings or any other engineering geology book also. So the correct answer of this question will be quartzite. Next question is, when the river section is wide and foundation is unsound, suggest the type of dam preferred. Foundation is unsound means foundation is not strong. So first one is gravity dam. Gravity dam, the favorable sites for gravity dam is narrow valley, and strong foundation is also required. Why narrow valley? Why? Because gravity dam is a type of concrete dam, and this will be very much effective. Gravity dam is very much effective in narrow valley because the construction cost will be high if you will develop gravity dam in a wide valley. Okay, next one is arc dam. Arc dam is also a type of concrete dam. It also need concrete, but the difference is that in arc dam the wall of the dam is arc shape, okay, and it is also generally developed in narrow valley and strong foundation. Now multiple arc dam, I think multiple arc dam will also need I think a strong foundation or something like that, or if it doesn't if it also doesn't need a strong foundation, then developing multiple arc dam in a wide valley will be much costlier than embankment dam. Why? Because embankment is the site which is favorable for constructing embankment dam is wide valley, and it also doesn't require a strong foundation. Can be founded, can be, or you can say can be developed on firm soil also. This is a type of earth dam also, you can say. And the favorable site you can check in any book, that you can say in Subino Padhyay, or you can say Subino Gangopadhyay or Parveen Singh that the favorable site for embankment dam is mentioned there, that wide valley, and it also doesn't require strong foundation. So according to me, the correct answer of this question, or the favorable dam which can be developed in a wide river section and where foundation rock is unsound. So the correct dam which should be prepared is embankment dam. But let me know in comment section if you have any reference or any idea about multiple arc dam, please. Next question is, ilmenite is separated from chromite by. So ilmenite is FeTiO3 and chromite is FeCr2O4. Now these both have approximately similar specific gravity. So though separation of ilmenite from chromite is done by all these methods, gravity separation, magnetic separation, electrostatic separation, but because the difference between specific gravity is not too high, so it will not be. Gravity separation method is mainly used to separate light and heavy ore mineral. Okay, now magnetic, coming to magnetic separation, you can see that chromite is slightly slightly magnetic, but ilmenite is, I think, is slightly more magnetic than chromite. So magnetic separation can be used to separate ilmenite and chromite. This is most favorable, in my opinion, that magnetic separation can be used to separate ilmenite and chromite. Froth flotation process, this is not the correct process to separate ilmenite and chromite. Why? Because it is used to separate and concentrate ores that are either repelled or attracted by water, basically, or you can say generally sulfide ores. So the correct answer of this question will be magnetic separation. Now next question says, gravity separation methods can be applied for structural studies in. So what is gravity separation method? Gravity methods are used in exploration, and these are based on detecting variations of the Earth's natural gravity field. And the surface gravity at a surface location is a function of the rocks underneath. Okay, and now it may be either, so clearly the surface gravity at a specific location is a function of rocks underneath. So now this rock may be sedimentary, maybe metamorphic, and maybe igneous also. So gravity methods can be applied for structural studies in all the sedimentary, metamorphic, and igneous terrains. Next question is, in a complex pegmatite, the zone that is richest in the economic minerals is. So first one is intermediate zone, second one is wall zone, third one is border zone, and fourth one is core. Now, core, basically in core, it mostly contain quartz, but may also contain feldspar, tourmaline, and spodumene. So this is not the zone that is resist in economic minerals. Coming to border zone is a fine grained zone in which it is composed of apatite and it is also very thin. Apatite, you can see this is a hyperbasal counterpart of granite. So it is also not the richest in economic minerals. Next one is wall zone. Wall zone, it is coarsely crystalline and contain muscovite and beryl. So this is somewhat economic purpose, use of economic purpose, but still it is not the richest zone. Next one is intermediate zone. Intermediate zone, this is enriched in valuable economic minerals like cassiterite, spodumene, beryl, muscovite, etc. So the correct answer of this question, that the zone which is resist in economic minerals in complex pegmatite, is intermediate zone. Next question is, Kudremukh in Karnataka is famous for. So Kudremukh in Karnataka is situated in Chikmagalur district, and it is having very high rich deposit, very rich deposits of magnetite ore, and these are first discovered by Sri P. Sampath Iyengar, a renowned geologist, and these are one of the largest iron ore producing mine in the world also. So let's check the options. Copper deposits, hematite deposits. Copper, no. Hematite deposits, no. Though these are iron deposits, but the most ore, the ore that can be extracted from Kundramukh mines in Karnataka are magnetite deposit. This is also incorrect. So Kudremukh in Karnataka is famous for magnetite deposit. Next question is, which of the following is an ore of tungsten? So to answer this question, you should know the composition of all these ore. First one is wolframite, second is hafnirite, and third one is skillite. Now, wolframite, for if you see the ore of tungsten, you will see that it is grouped into wolframite series. Wolframite series contain hafnirite and ferberite. The composition of hafnirite is MnWO4 and ferberite is FeWO4. Next one is skillite, and composition of skillite is CaWO4. This is the last question in every exam. So the correct answer will be all of the above, because all these three minerals are ore of tungsten. So that's it for today. Thank you guys for watching this video. If you love the content, please click the like button. Don't forget to subscribe the channel and share among your friends. Thank you. And yeah, one more thing, please save electricity.